Welcome to This Explainer. Okay, today we are totally deconstructing that massive, frankly intimidating wall of trig formulas you've probably stared at in a textbook. You know the exact one I'm talking about. It's crammed with symbols, numbers, and rules that just seem to go on forever. But here's the secret. It's not a wall at all. It's an engine. And today, we are going to focus specifically on unlocking how double angle formulas work, because understanding them is the absolute key to making this entire engine run smoothly. Let me ask you something. When you stare at a page filled with dozens of trigonometric rules, do you really need to memorize all 40 of them? Does anyone actually have the mental bandwidth for that kind of rote learning, unless you're a literal human calculator? I know that triggers a lot of anxiety for a lot of us. But what if I told you there's a vastly better way to handle these formulas, a way where you memorize almost nothing at all? Okay, let's dive right into our roadmap. We're going to hit the memorization myth, the trigonometry engine, unlocking double angle formulas, the domino effect, and wrap up with one system, not 40. Section 1. The memorization myth, breaking down the illusion of rote learning. Section 2. The trigonometry engine, the foundational parts that build everything. You know, when you glance at a full textbook page of trig functions stretching from 2 alpha all the way to 4 alpha and half alphas, it can overwhelm absolutely anyone. But it's an illusion. The book is not giving you 40 unrelated rules. To beat this, we've got to adopt an engine builder mindset. The very first gear in our engine, you probably already know it. It's the basic identity. Sine squared alpha plus cosine squared alpha equals 1. This is our foundation, and this single gear is literally what's going to help us transform everything else later on. Next up is our primary blueprint, the sine of a sum. To find the sine of two angles added together, alpha plus beta, you basically just make two products and add them up. Sine alpha times cosine beta plus cosine alpha times sine beta. That's it. This is the main blueprint we're going to use to build almost the entire system. And right alongside that, we've got the cosine version of our engine base, the cosine of a sum. It's cosine alpha times cosine beta minus sine alpha times sine beta. Now notice how cosine addition actually uses a minus sign? Keep that tucked in the back of your mind, because these addition formulas are the core mechanics driving everything we're about to do. Section 3. Unlocking double angle formulas. The magic trick of substitution. Okay, here is where we perform this brilliant yet incredibly simple transformation to see exactly how these double angle formulas work. Step 1, we literally just take our blueprint, the sine of alpha plus beta. Step 2, instead of calculating two completely different angles, what if we just substitute beta with a second alpha? We just set beta equal to alpha. That instantly makes the left side the sine of 2 alpha. And on the right side, both terms suddenly become sine alpha cosine alpha. Step 3, we just combine those identical terms. Which brings us to step 4, revealing our result. Sine of 2 alpha equals 2 sine alpha cosine alpha. Look at that, we just magically birthed the double angle formula without having to memorize a single new thing. So the absolutely crucial point here is that while these look totally different on a printed page, mechanically, they are identical. That quote-unquote complex double angle on the left is literally just the basic addition formula on the right. It's just wearing a clever disguise where both angles happen to be the exact same size. And guess what? We can apply this exact same substitution logic to our cosine addition formula. Start with the cosine of alpha plus beta. Now put beta equal to alpha. The left side instantly becomes cosine of 2 alpha. The right side, it becomes cosine alpha times cosine alpha, so cosine squared alpha, minus sine alpha times sine alpha, which is sine squared alpha. Boom. We just generated the double angle cosine formula just by turning a crank on the engine we already built. And this brilliantly illustrates our neatly organized completed tools that we literally built from scratch. Whether you're looking at sine, cosine, or tangent, every single double angle formula simply derives straight from its basic addition formula counterpart. By just understanding how to swap out beta for alpha, you've conceptually mastered a huge chunk of your textbook. Section 4. The domino effect. Unlocking the rest. Because I'm telling you, once that 2 alpha gear starts turning, everything else falls into place like dominoes. Let's look at some even more complex territory, like the triple angle and 4 angle formulas. Figuring out 3 alpha isn't some brand new rule you have to commit to memory. It's really just plugging our double angle back into the machine alongside a single angle, 2 alpha plus alpha. What about 4 alpha? That's just applying the double angle formula twice over, 2 alpha plus 2 alpha. This identical logic just cascades all the way down the page. And it even works in reverse. If we want to make the angles smaller instead of bigger, we just throw the engine into reverse. We start with that double angle cosine formula, set 2x equal to alpha, and just rearrange the terms to solve for the half angle. With just a little basic algebra, it effortlessly spits out the half angle sine formula. Once again, the whole thing is powered by that original simple engine. This foundational logic even lets us pull off incredible transformations, like the sum to products transformation, meaning we can literally change addition directly into multiplication. By playing around with adding and subtracting our basic blueprints, we can take something clunky, like sine of 60 plus sine of 30, and turn it directly into 2 sine of 45 times cosine of 15. That complex ratio just morphs into a much cleaner calculation. Section 5. One system, not 40, the power of the foundation. As we wrap up this explainer, I really want to hammer home our core theme. We didn't just memorize random rules today, we actually learned how to build them. We saw the underlying architecture. I want to read this powerful takeaways straight from our source material. Most of the page is generated from just addition and subtraction formulas. Once those foundations are understood, the rest become transformations rather than memorization. That perspective shift is a real game changer. It turns this overwhelming wall of math into a fun, creative puzzle. So, I'll leave you with this final thought to chew on. If understanding the basic foundation completely eliminates the need for all this memorization in trigonometry, what other complex systems in your life or your studies can you master simply by finding the underlying engine? It's time to become an engine builder, not a memorizer. Thanks for joining me on this explainer, and keep building.